Welcome to ShreeKrishnaEducational channel. In this video I am going to introduce the new chapter of class 12th chemistry, that is amines. So first let me discuss the introduction of amines. So amines, which are consisting the ammonia consisting the hydrogens which are replaced by the alkyl or aryl group. So that case we can get the important organic compounds like amines. So here these amines which are naturally occur as well as the synthetically also which can be observed. So naturally occurring amines, those are the proteins, vitamins, alkaloids, hormones. So these are the naturally occurring amines. The synthetic amines like polymers, dyestuff, drugs, so these would be comes under the synthetic amines. There are some compounds like adrenaline, epihedrine. These are the biologically active compounds which are consisting the secondary amino group, which are mainly used to increase the blood pressure. So that case we can, these biological activity compounds can be useful. And other compound like novocaine, it is a synthetic amino compound which can be used in the anesthetic in dentistry during the dental surgeries. So here the novocaine can be used as a anesthetic agent. Next, Benadryl, it is a well-known antihistaminic drug. It can be consisting the tertiary amino group. It is mainly used in the case of the cough syrup. It is mainly used as a cough syrup. And the quaternary ammonium salts, which are used as surfactants. In addition to these, the amines also forms other kind of compounds like diazonium salts, which is consisting the azo group. So these diazonium groups which can be helpful to prepare the different kind of aromatic compounds including the dyes. Next, the amines. So in this case when the alkyl group replaced by one of the hydrogen of ammonia, so that case we can get the amines. At the same time the aryl group also can be replaced the hydrogen, so that case also it forms the amines. In case more than one hydrogens of ammonia, that case also it leads to formation of the amines. So here the two alkyl groups are replaced by the two hydrogens of amine, that case also it forms the amine. And in this case there are three alkyl groups which are also replaced by the three hydrogens of ammonia, so this case also we can get the amines. Next, the structure of amines. So in the case of the ammonia, so which undergoes sp3 hybridization. So whenever the sp3 hybridization, its bond angle would be 109.5, that is a bond angle. But in case of this amines, the bond angle would be 108. 108. The bond angle is reduced from 109.5 to 108, though it undergoes sp3 hybridization. So this is because of there is a repulsion between the lone pair and bond pair, as well as the bond pair and bond pair. Due to these repulsions, the bond angle is reduced from 109.5 to 108. Similarly, the shape of the amino compounds also reduced from tetrahedral to pyramidal. So this is also due to the same reason. Next, the classification of the amines. Amines are mainly classified into primary, secondary, tertiary, that is depends upon the number of hydrogens of ammonia replaced by the alkyl or aryl group. If suppose the ammonia consisting the three hydrogens, one of the hydrogen is replaced by the alkyl group, it would be comes under the primary amine. If the ammonia consisting the three hydrogens replaced by the two of the alkyl groups, so that case it would be comes under the secondary amine. The ammonia consisting the three hydrogens which are replaced by the three alkyl groups, so that case which is known as tertiary amine. In case sometimes the alkyl group also replaced by the aryl group, so that case also which can be forms the amines. And if the alkyl group or aryl groups those are same, so that case which should be comes under the simple amines, those are different, so that case it would be comes under the mixed amines. Next topic that is nomenclature of amines. So in this nomenclature, first one, the common nomenclature. The common name of amines which is simply comes as the alkyl amine. simply it is for example if we are taking CH3NH2. So in this case the methyl amine is the name, alkyl amine would be come here. In the case of secondary and tertiary amines, when the two or more groups which are same, so that case we need to keep the di, tri as the prefix to the alkyl group. Before the alkyl name we have to write to di, tri, that is depends upon the number of same groups which are present in the case of the amine. Next, the IUPAC system. In this case, the amines which are simply considered as alkyl amines, alkane amines, which can be considered. So in this alkane amines, alkane at the end E, which is replaced by the amine. Alkane at the end E, which is replaced by the amine. So for example, CH3NH2. So that is methyl amine in the case of the common name. While we are writing in the case of the IUPAC name, we can write as methane amine. Is the IUPAC name. In case more than one amino groups which are present, so that case we need to use the parent carbon chain. First we have to write. So in this case the at the alkane at the end we E to be retained, and we can mention the position of these amines in the parent alkane chain, and after that we have to write the di or tri, that is depends upon the number of same amino groups, and after that we can write amine. So for example NH2 CH2 CH2 NH2. So in this case the name would be as ethane 1,2 diamine. So this would be the name of the compound. So here the name alkane name at the end E to be retained, and we need to mention the position of these amino group, and the depends on the number of amines. Okay, di, tri, tetra, the prefix name we have to write before the amine. In the aryl amines, so the NH2 group which is consisting the benzene ring, so it would be comes under the aryl amine. So simply it is C6H5NH2, this simple aryl amine. So in this case the aryl group which is present, the name of this compound is aniline is the common name. The IUPAC also accepted this aniline is the IUPAC name. Okay, aryl amines, okay, in the case of the IUPAC system, the suffix E, okay, which is replaced by the amine. So for example this one C6H5NH2, it is benzene amine. Okay, benzene amine. Now benzene at the end E which is replaced by the amine. So this is the nomenclature of amines, both aliphatic as well as the aromatic amines. There are some examples of these amines. Here see CH3 CH2 NH2. So common name is ethylamine, IUPAC name is ethanamine, and other one is CH3, okay, CH2 CH2 NH2. It is N-propyl amine is the common name. IUPAC name is propane 1 amine. There is a one more possibility also can be possible. So because of that we need to mention the position of the amine, 1 amine. And other one is CH3 CHNH2 CH3. So it is isopropylamine is the common name, and the IUPAC name is propane 2 amine is the IUPAC name. The next one CH3NH CH2 CH3. So this is known as ethyl methyl amine is the common name, and the IUPAC name is N-methyl ethanamine is the IUPAC name. And other one is CH3N CH3 CH3. It is a tertiary amine. So this is common. Its common name is trimethyl amine is the common name. IUPAC name is NN-dimethyl methanamine is the IUPAC name. Okay, next compound is C2H5 C2H5N CH2 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 CH3. So this common name is this compound common name is NN-diethyl butyl amine is the common name. IUPAC name is NN-diethyl butane 1 amine is the IUPAC name. The next one NH2 CH2 CH double bond CH2. It is its common name is allyl amine is the common name. IUPAC name is prop 2 in 1 amine is the IUPAC name. Next one NH2 CH2 4 time NH2. it's known as hexamethylene diamine is the common name. IUPAC name is hexane 1,6 diamine is the IUPAC name. Okay, in case of the aromatic compounds, like on the benzene if the NH2 is present, so its name is aniline is the common name. IUPAC name also aniline, IUPAC also accepted aniline, and we can also write as benzene amine. And substitution in the case of the benzene ring, in the case of amines, so the CH3 group is present on the aniline, so we can write as orthotoluidine is the common name, and the IUPAC name is 2-aminotoluene. Okay, this is the IUPAC name. Okay, next in the case of the halogen which is present, bromine which is present at the 4th position, so that is known as parabromoaniline is the common name. IUPAC name is 4-bromobenzeneamine, or also we can write as 4-bromoaniline. Okay, in case of the benzene ring consisting the N, okay, which is having the 2-methyl group, in that case we can write the common name as NN dimethylamine. Dimethyl aniline is the common name. IUPAC name is NN dimethyl benzeneamine is the IUPAC name. So this way we can write the names of the amines. Next, preparation methods of amines. So in the case of the preparation methods, first one is the reduction of nitro compounds. Okay, in this case, when the nitrobenzene which undergoes the reduction in presence of the palladium, platinum or nickel, which undergoes hydrogenation in the presence of the solvent like ethanol, that case it converts the NH2 group on the benzene ring. So NO2 group can be converted into NH2 group. So this is the oxygen can be removed, so it is a reduction. Simultaneously the hydrogen is added to the nitrogen, so it is a reduction. Next, the same nitrobenzene, when it is treating with SN, tin plus hydrochloric acid or iron plus hydrochloric acid, so that case also the reduction can be takes place. The nitro group can be converted into NH2 group, amine group can be converted. So this is also reduction. So here we can use the reducing reagents to convert the nitro group into amine as hydrogenation in presence of the platinum, palladium, nickel, or tin plus hydrochloric acid, or we can also use iron plus HCl. So that case the nitro group on the benzene ring can be converted into amine. Next, another preparation method, that is ammonolysis. So in case of the ammonolysis, when the ammonia which is having the pair of electron on it, so when this ammonolysis, the ammonia which is treating with the alkyl halide, so that case it forms the salt, ammonium salt initially obtained. So this pair of electron which can be attacked on the alkyl group of the alkyl halide, so the halogen can be left as halide ion. So that case it forms RNH3 plus here the nitrogen having a positive charge and halogen has X minus. So it is a substituted ammonium salt is obtained. Now the substituted ammonium salt which can be further decomposes, it gives the corresponding amine. So hydrogen halide can be removed from it and forms the corresponding amines can be obtained. So when the primary amine which is further treating with the alkyl halide, that case we can get the secondary amine. Now the secondary amine treating with the tertiary another alkyl halide, that case we can get the tertiary amine. The tertiary amine treating with the alkyl halide, that case we can get the quaternary ammonium salts. Okay, that is R4N X minus can be obtained. Okay, from these the free amine can be obtained from the ammonium salt by the treatment with the strong base. When the strong base which is treating with this salt, so that case we can get the free amine can be obtained. So here we can get the substituted ammonium salt, that is RNH3 plus X minus, which is treating with the strong base like sodium hydroxide. That case it gives the primary amine. In addition to that it will give the water and sodium halide. So this is this way we can get the free amines from the salt. This process is known as ammonolysis. So in this case we can get the mixture of products like primary, secondary, tertiary amines can be obtained. Among these the reactivity of the alkyl halides. Among these, the alkyl iodide which is more reactive towards the reaction with the ammonia than the alkyl bromide than alkyl chloride. So this is due to the cleavage between the alkyl and iodide, so which can be very easily cleaved, so that it can be highly reactive towards the ammonolysis rather than alkyl bromide and alkyl chloride. Next, the reduction of nitriles. Okay, when the nitriles, that is cyanides, alkyl cyanides, okay, which are undergoes the reduction in presence of the nickel, platinum or palladium, undergoes hydrogenation. That case which can be converts the amines, nitriles into amines, or this reaction also carried out in presence of sodium amalgam in the presence of ethanol. That case also we can get the amines. Okay, in this case the nitrile group C triple bond and can be converted into CH2NH2. It is obtained the primary amines. Next, the reduction of amides. Okay, amides is RC double bond O NH2. And the amides which is treating with the lithium aluminum hydride, it is a strong reducing reagent. Okay, followed by the hydrolysis. That case which will gives the corresponding amines. So here C double bond O group can be converted into CH2 and gives the primary amine. Here also we can get the primary amines. So here the amides can be converted into amines. So in this case also can use the reduction. So here the strong reducing reagent lithium aluminum hydride can be used. So in the presence of the lithium aluminum hydride, the reduction can be carried out. And other preparation method, that is Gabriel phthalimide synthesis. So in case of the Gabriel phthalimide synthesis, so in this case the phthalimide it is nothing but on the benzene ring which is consisting C double bond O NH C double bond O, which is initially treating with the strong base like sodium or potassium hydroxide. It forms the salt of the base. By use of the water molecule, it forms the salt as benzene ring C double bond O N C double bond O K. This can be obtained. Now this salt of the phthalimide which is treating with the alkyl halide. That case it forms the alkyl group. Instead of the potassium, the alkyl group which can be replaced, and the potassium and halogen which can be lived as potassium halide. Now the alkyl group in case of the N-alkyl phthalimide which is treating with the strong base like sodium hydroxide in the aqueous medium. That case it can be dissociated to give the sodium phthalate plus primary amine. Okay, primary amine can be obtained. So this way we can get the primary amines from the phthalimide. Initially phthalimide is treating with the strong base like sodium or potassium hydroxide. It forms potassium phthalate. Now the potassium phthalate treating with the alkyl halide, it gives the N-alkyl phthalimide. Now the N-alkyl phthalimide is treating with the again strong base. That case we can get the sodium phthalate plus the primary amine. Okay, next the last preparation method, that is Hoffman bromide degradation. Hoffman bromide degradation. So in case of the Hoffman bromide degradation, so in this case the amides, amides which can be treating with the bromine water in presence of the strong base like sodium hydroxide. That case it can converts into primary amines. Amides can be converted into primary amines. Okay, in addition to that sodium carbonate, sodium bromide and water can be obtained. So here the amides can be converted into amines. So here one of the carbon which can be reduced from the amide. Here C double bond O group is simply removed from this and the bond can be takes place between the alkyl group and NH2. So that case we can get the primary amine can be obtained. This is the one of the carbon which is reducing from the amide. So because of this this reaction is known as degradation, Hoffman bromide degradation. So this is the preparation method of the amines. Okay, thank you.